Thank you for the introduction. So as you see, the title is quite a shift from what we've been talking about so far, about human nutrition. This is focused on pets nutrition. So I'm from Hills Pet Nutrition. If you know, it's located in Kansas, in Topeka. We work in the research. I work in the research department, mainly focusing into ingredients, screening ingredients that are beneficial towards modifying the gut microbiota. So even if it's a little bit different from what we've been talking so far, I know it's related because if you have seen one of the articles that came out this year from the University of Alberta, looking into how the infant microbiome is modified by whether the household has some pets or not, and they clearly showed in a longitudinal study following the infants from the time they were the mothers were pregnant until they were 3 months. So that's a study following the infants from 2009 to 2012, and they showed there is an increase in certain genera of bacteria, like Ruminococcus or Psilospira, which are beneficial in terms of preventing risks associated with obesity or allergy. So pets are really important source of the good microbiota if they are fed the right kind of fibers to stimulate the growth of those bacteria. So here my presentation will be focused on senior pets. So we looked into dogs and cats between the ages of 8 and 16 years old and looked into different fiber sources to see whether the microbiota of the senior pets shifts from what is known mainly from human literature, which is young kind of microbial population versus senior microbiota. And we've considered aging as one of the chronic conditions because it's associated with inflammation. So from what we know from scientific literatures based on human studies is that as we age, the number of potential pathogenic microorganisms such as Clostridium, Eubacterium, and Staphylococci go up, while the abundance of those bacteria associated with benefits such as production of short-chain fatty acids or degradation of other complex fiber components into useful metabolites go down, and those includes the famous bifidobacterium, which is considered as safe and sold as probiotics, and the others, including Ruminococcus or Psilospira, which I just mentioned, to increase in household with pets and to decrease the chance of getting obese or allergy. So those beneficial microorganisms go down with aging, while the potential pathogenic ones go up. So in this study on dogs, in the senior dogs between 8 and 13 years old, we formulated 2 different types of food. One is a test food, which is kind of new. It's Youthful Vitality. It contains fiber sources from vegetables mainly, carrot granules, tomato pomace, spinach powder, and citrus pulp. And on the other hand, we have another control 2 diet, which uses whole grains mainly as source of fiber, which is sorghum and wheat. There is a control 1 diet, which doesn't contain any of these fiber sources. So the design of the study looks like this. We have 36 senior dogs, which we put first on control 1 diet, which didn't contain any of the fiber sources, for 1 month. And then we split the dogs into 2 groups to receive one of the diets, which contains either the whole grain sources, which is control 2, or the vegetable plus fruit sources, the test diet. So each were fed for 1 month, and then we put them back on the control 1 diet, kind of a washout period, and then we did crossover. We really believe in doing crossover designs due to the individual variations when it comes especially to microbiota. So, and then at the end, they were put back on the control 1 diet. So we collected fecal samples and blood samples to analyze microbiome as well as metabolites. So mainly, the results focus the comparison of those endpoints on tests versus the control 2 diet. I'm not including the data from the control 1 here, which is considered as a washout phase. So what we saw is the test diet, which contained vegetable and fruit sources, increased these genera significantly. So the y-axis shows you the difference in the percentage of the genera when the pets were on tests versus the control 2 diet. So anything above 0 shows you an increase in the genera. So all the 4 considered beneficial microorganisms went up in the senior dogs after the consumption of the diet. So we believe in looking into metabolites as well in order to see whether this is a benefit or not. This is a fecal metabolites results. The first one is pyrraline. Pyrraline is, as you know, is an advanced glycation end product. And advanced glycation end products are formed by the glycation of amino acids, which result to the formation of non-functional kind of proteins or any other components that the body needs. So that leads to different kind of age-related diseases. So pyrraline, as you see on the y-axis again, that's the same difference, simple subtraction of the relative amount of pyrraline on dogs on test food versus control 2 food. And all dogs, each dot represents actually a pet, which is a dog. So almost all dogs had significantly reduced level of the advanced glycation end product. And the second one is threonine, which is interesting because we've been talking about mucin degradation. So we don't want to increase the bacteria which lead to mucin degradation. And threonine is the amino acid which is associated with increased mucin degradation in the gut. And you want that to be down in feces. You don't want high level of threonine. And as you see, the test diet decreases threonine significantly. Glycerol is interesting. It's increased on the test diet because most of them had a value above 0, which shows a higher level on the test diet. And we believe that glycerol has the effect of increasing moisture to the stool. And we have been talking today about how moisture is important in terms of loosening the stool and also shortening transit time. And the shorter the transit time, the lower the amount of putrefaction products, which cause other kind of complications, diseases. So glycerol increase, that's what we saw in the feces. And we had also blood metabolomics from plasma, and similar trend with the fecal metabolomics. Pyrraline went down significantly. And the other interesting metabolite we looked is for ethylphenyl sulfate, which is exclusively microbial product, which is associated with brain function. So this metabolite is known to increase in people with autism and other brain disorders. So you want this metabolite to go down. And as you see, the test diet reduced the amount of this metabolite. The other markers we looked are kidney associated. And with pets, mainly with cats, as they age, they tend to develop kidney diseases. And we looked into markers of kidney health, like SDMA. SDMA goes down a little bit, statistically significant reduction in SDMA after feeding the test diet. And the other marker is 3-methyl-catechol sulfate, which is a microbial uremic toxin that was also significantly reduced on the test diet. So really from here, from the canine study, we saw improvement in brain health or overall age-related conditions. And from the cats, we used kind of similar ingredients, mainly vegetable source fibers, pea fiber, broccoli powder, and tomato pomace as source of fiber sources. And the control 2 had beet pulp and wheat as source of fiber. Same design like the dogs, except with the cats we had 40 dogs. And we didn't do fecal metabolomics in this case, we did blood metabolomics and microbiome. So the interesting result in cats is bifidobacteria was significantly higher on the test diet. And this was quite interesting to us because back in the old definition of prebiotics, I think it was a requirement for a prebiotic to increase bifidobacteria specifically, and that was clearly accepted as a prebiotic effect. So kind of bifidogenic effect of this test diet was significant. And with this increase in bifidobacterium, other bacteria decreased, which are Clostridia and eubacteria. Normally, this bacteria increase with aging, but the test diet kind of reduced this trend. Looking into the metabolomics, a lot of markers associated with kidney disease were improved by the use of this specific combination of fibers. So the first markers we've been talking early this morning were indole sulfates. Those are products of putrefaction or protein fermentation from the amino acid tryptophan. So indole gets converted to sulfate in the liver, and in case of kidney compromised conditions, that becomes really toxic. So both indole compounds were reduced significantly, and the other markers that we know, like blood urea, creatinine, STMA, along with ADMA, were reduced significantly on the test diet. And also, guanidinoacetates are known to have kidney damage effects. They were reduced. On the other hand, homoarginine, which is mainly produced in kidney, is improved, like 15-fold increased in homoarginine. The other markers we saw are like the ones in the canine study, pyrraline, the advanced glycation end product, and the brain metabolites, which is for EPS. Both of them were significantly reduced by using this diet. So really, to conclude, what we saw was from the canine test diet, we saw a different group of bacteria which were induced by the test diet, which are mainly butyrate producers, Ruminococcus, and Oscillospira, known by degrading complex fibers found in plants. They were also significantly increased, and Slackia and Doria. So those were associated with a change in metabolites, associated with aging, gastrointestinal, kidney, as well as brain health. So we saw a different kind of effect on the feline side. We encountered bifidobacteria mainly in cats compared to dogs, and the test diet increased the number significantly. And markers of aging, kidney, as well as brain were also improved. So all in all, the conclusion was like that fibers, pets need fibers as well, and especially when they originate from vegetables and fruits, they give significant benefit. I would like to thank my colleagues, Dr. Dennis Jewell and Matthew Jackson from Health Pet Nutrition. Thank you for your attention.
Thank you very much, Eden.
Thank you.
Any question? We have time for question. No? Oh, yes, Joanne.
Very nice presentation. I have a question about the different fibers. So when you're comparing, it's a whole grain fiber versus a fruit vegetable fiber, is the fiber content the same, the total?
Mm-hmm, yeah.
And soluble versus insoluble, is that different?
They were comparable, the same. They were not different. It's just the source which was different.
So what's the mechanism? What would, if we believe in fiber and soluble versus insoluble fiber being the mechanism, and these, the test, and the only difference is fruit vegetable versus whole grain. So any ideas of what's causing your differences?
I believe it all leads to the structure and the complexity of the fibers present in the different sources, but really the mechanism is not clear. But we know that the plant sources, like vegetable source fiber, are a little bit complex, and the microbiome is also different associated with that. So, for example, Oscillospira increasing when you add vegetable kind of fiber instead of grain source fiber. So really the details of the mechanisms are not so clear, but I think it's the
It might not be
structure.
fiber at all, but it might be other compounds in fruits and vegetables.
Yes, polyphenols and others, which are also part of, could be, yeah. Yeah, thanks.
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 I have a stupid